Welcome back to VTU e-Shikshana program on computer aided engineering drawing. Now we have to start module 3, which deals with basics of sections of solids, which is prerequisite to deal with development of surfaces. Actually we are working on more on development of surfaces. To know the basics of the sections of solids, you have to consider simple solids like square prism, square pyramid, rectangular prism, and other activities like the pentagonal prism, hexagonal prism, and section planes inclined at some degree to HP, some degree to VP, like this. Now let us start working a problem on the rectangular prism. Before that, let me tell you what exactly the development. Development actually is the very important chapter or the topic to deal with. It uses in many industries, particularly packaging industry, and also the industries, heavy industries which are having the refrigeration units, which requires the ducts of different sections. For that we need the development of surfaces. Applications are vary with the type of industry. Now we have the simple solids, rectangular prism. Unlike the projection of solids, here we never try to incline the solid to any angle, to any principal planes. We keep that particular prism or pyramid on its base and discuss the development of the surfaces. Here let me discuss the position of the solids which is on ground, which is having base on the ground. That orientation is important here, rather inclination to axis. No inclination to axis, but orientation of the base surface which is on ground is very important. Now let me discuss this, very simple. This rectangular prism is having the longer base edge, smaller base edge. The longer base edge is parallel to VP, smaller base edge is perpendicular to VP. If I keep it like this, longer base edge is perpendicular to VP, smaller base edge is parallel to VP. So this is how we can have the status of the base of the solid. So if I take up the prisms, very simple prism, this one, this is square prism. The base sides are parallel, two base sides are parallel, that means number 1, number 2. These two base sides are parallel to VP, and two more base sides are perpendicular to VP. If I say a base side is perpendicular to VP, same position. If I give a base side is parallel to VP, same position will work for that also. Unlike the rectangular prism, because rectangular prism we have two type of sides. Here this particular orientation works for both the questions. Now if I keep it like this, all base edges are equally inclined to VP. These are making 45 degree to VP. If I keep one diagonal parallel to VP, definitely these sides, all sides are inclined at 45 degree. This is characteristic feature of square. Suppose that I don't want either parallel to one side parallel to VP or perpendicular to VP, or all sides are equally inclined to VP. I want a particular side inclined at 30 degree to VP or 45 degree to VP. 45 degree, this itself work. Other than 45 degree, say 30 degree to VP or 60 degree VP, definitely I can place one of the side inclined at some degree to VP. So this is how we can vary the situation in development of surfaces, because it may require, this type of situation may require in applications. So that's why we are going to deal with. Other than this, we are going to deal with ducts also. At the end of this session, the module 3 session, we will work out that, particularly under applications. Okay. Now let me take one by one simple models and then explain the corresponding developments. See, here I have a square, and assume that there is a requirement for covering this lateral surface of the square with a costly surface model, that is the material, you can say, sheet. In that case, you have to optimally work out. So, how to work out? First, we have to take this particular position and see that this particular solid is having how many surfaces? 4. And let me have the top view and front view of it and then try to develop. Okay. Now, what I have to do is, I will cut at this particular edge, longer edge. Assume that I have a wrapper and then open it like this. Now, I got the development. This has got 4 segments, 1, 2, 3, 4. Each segment base is equal to side of the square prism and height equal to length of the axis. That's all, very simple. This is for square. If it is triangular prism, 3 items like this, 3 segments. If it is pentagon, 5, 6 for hexagon. That's all. There is no change in the procedure. We will discuss that at length, how to work out the development. This is case of the square prism. Now I will take simplest and very important thing, rectangular prism. Assume that again I have covered this with a sheet of paper. Then I see that the surface is completely intact and covered. I will take out at this particular point or longer edge. Then see, you have development. Here is smaller side, here is the longer side, and smaller side, longer side, and ulta also is possible. That again depends on how you take, how you keep the orientation. First you have to start with an edge, the starting of the shorter edge. Otherwise, it will be like this. First you will get longer edge, then smaller edge. Again, you see that the sides are different. What happens in hurry? We work with a single side, treating that as a development. It is wrong. Actually, we have smaller side, longer side, alternately we get. So, this is how you get the development of the rectangular prism. Okay, we will discuss that in detail with the procedure. Now, let me take the pyramid. I have a square pyramid here. I have a square pyramid. Assume that again I have taken surface into consideration. Okay. As usual, we will have the position of the solid. I will keep it on the ground base. I will keep it on the ground with the given condition. In this case, I have one side is parallel to VP or one side is perpendicular to VP, that you know. Now, I will cut at this slant edge, this particular item, surface, extra surface area. Then I will remove it and keep it on the flat surface. That is very important. Keep it on the flat surface. Now, this particular item is referred to as development of surface. All are true lengths. Even in case of prisms, we are having true lengths. These are slant edges. All slant edges are equal. And these are base edges. It is very easy to draw. I will show you one by one. Assume that this is a right regular cylinder of particular diameter and height. And again, I will cut at a particular generator. Infinite number of generators are there. And open. This is simply rectangle. What about the length of the development? Length of the development equal to 2 pi r, that is pi d. Okay. Now, what about height? Height equal to axis. Very simple way of working development of a cylinder. Now, development of a cone. Suppose that I have a cone of specific dimensions. Base dia is 50 mm, height equal to 60 mm, etc. Then this particular radius is very important. Diameter or radius is very important, and also height. There is a procedure to draw that. After you draw and get the development, you will get this. this angle is pi, that depends on the radius. Okay, there is a particular formula we will work out one by one. So this cannot be always 90 degree, this can be any value. Okay, any value within, it can be the value of more than 180 or less than 180. Okay, it may reach 360. If it reaches 360, it becomes a flat surface. Okay, it cannot be any cone. Okay, so always between 180 and 300, around like that will be there. That all depends on the height of the cone and base circle. Okay, now let us discuss the actual problem here one by one. A rectangular prism of base 40 mm by 20 mm, height say 65 mm, has its base on HP, such that one of the longer side is parallel to VP. He has specifically given longer side is parallel to VP. It is cut by a section plane inclined at 45 degree to HP and passing through the top extreme edge of the prism. We will take up that at the next stage. First stage, let me draw the projection of the given solid in the required position. Now you know how to draw the rectangle. So longer side and the one of the longer side is parallel to VP. So always you must consider this particular reference. Longer side is parallel to VP. Okay. Now complete the rectangle 40 by 20. Okay. Now start with A, B, C, D. Have the center of the top view with light lines. This is O1. You can also have A1, B1, C1, D1 in bracket, not necessary. Project this up. See that this is 60 mm, 65 height. Now project the axis also. Name these points. A1 dash, B1 dash, C1 dash, D1 dash, A dash, B dash, C dash, D dash. Dimension it as per the requirement. And like any other polygon, we have rectangle, we have to dimension the longer side as well as smaller side of the rectangle. This is 20 and this one is 40. 40, 20, height is 65. Yeah. Now, the projection of solids when the rectangular prism having longer base side parallel to VP. So naturally the axis is perpendicular to VP. We have O1. Okay. Dark this. If it is projection of solids with without any section plane. Then you have to dark all the things. Assume that I don't have any section plane right now. Draw just to have clear idea. Now, how to draw the development? Here we have x, y. Let me end y here only, and this is the portion for development. Parallel line method for all cylinders, prisms. Parallel line method is the best method, and it's the only method we use. Draw parallel lines. So this is not part of XY line, this is extended line. Now start with a vertical line. Now always start with A unless there is a requirement. If you get two-piece development, they are very particular about single-piece development, then you think of that. Otherwise, A is the best starting point. Now A1 is the best starting point. That is the, suppose that this is A1 is the left extreme nearest edge for you. Then you start from this and try to develop it. Now, let me name this as A1. Small size, capitals only. Then take here from A to B, longer side is there. Take longer side 40 mm and 40 mm. Name this as B1. Then height. Draw a thin line. B1. Next comes the smaller side. Okay. Smaller side you take. Okay. This is C1. Alternately you get longer side and smaller side. This one again I have C1, D1, then one more point is left. I will tell you, it's very easy to understand. Here I have the development A, B, C, D, again A, because if you join that to get the actual object after getting the development, you will get this is A, B, C, D, again A. Once you open it, you will get A, here also A. So that's why we always prefer to keep this again A1, this is A, this one is C, this is D. That's all. If it is development of the rectangle prism only, there is no section, then you have to dark all this. But here in this question we have the reference, there is a section plane inclined at some degree to HP. Then I will explain this clearly with a particular model, simple model, how exactly the section plane looks like. So assume that I have this model, square model. Then I will try to take section, top portion of the section perpendicular to VP and inclined to HP by 45 degree, passing through the right extreme top edge like this. Now suppose that this is the sharp edge and I will take this. This is the section plane. I will take out the one which is the top. Now it looks like this. See, here I have this and then I will remove it. Then you are left with this. Here it is, I have taken the axis as a reference, inclined at 45 degree through axis, midpoint of the axis. Assume that this itself is height of the prism. Then you have taken the section plane like this, perpendicular to VP, you have taken out the top portion. Then you get this particular. This is called section. Assume that it is solid, it is covered. This particular area is called the section. Okay. The view is nothing but sectional view. Okay. We will discuss that at length. This is about the development of the rectangle. Next, what about the development of the square? Again, square is the simplest model or the solid which we can discuss. Okay. Now, let me take up this particular solid. This is top view of square when one of the base side is parallel to VP. This AB and DC both you can take parallel to VP, or AD and BC are perpendicular to VP. Yes, as for A base side, it can be both, 2 or 1 only. So here 2 are parallel, 2 are perpendicular. You can take this. Now you consider this. Now draw projection. Height you fix. Assume that the height given is 60. Then draw the vertical lines. Okay. Then dark this. Unless there is section plane, assume that I am not considering section plane right now. I am considering only the complete development of the prisms. Now let me name this A1 dash, B1 dash, C1 dash, D1 dash, A dash, B dash, C dash, D dash. Then as usual, this is axis reference O1, O, this is O, O1 with a dash. Now, how to draw the development? Development, parallel line method, you fix the parallel lines. It's very easy job now. Let me restrict XY only to top and front views of the projection of square prism, and from this onwards it is for development area. Now take this by the side, you keep. Let me again start from AA1. See, this is the solid. I have A, B, C, D. I have to cut it. Assume that I am taking this part, particular longer edge into consideration, and then start developing. AA1. Then take the base side, say 40 mm. Given 40 and height is 60. You can also dimension here. Now take only one arc using 40 mm equal radius. Draw. Starting with this, it becomes 5. Now it's only 4 because already 1 you have fixed A1. Now draw lines through this. All are equal. Here we have alternately (40, 20). Please observe, it's very important. You can say length of the development capital L equal to total 2 times of this, that is 120. 40 plus 20, 2 times. Otherwise, you can dimension here also, not necessary. This is enough. Here, dimension this 1, 2, 3, 4, check twice. If it is pentagon, you have with particular orientation, overall development, there is no change. It's like this only. Irrespective of orientation, overall development, you will get same. Okay. 5, here only 4 is there, 5 for pentagon, 6 for hexagon, 3 for triangle. That's all. Okay. So, here this is single side, you dimension only once, and then total development, okay, 160. Okay, that's all. This is, assume that this is only rectangle. I have no section plane, complete lateral surface. I have to draw the development. You have to dark all this. Okay. I will utilize this figure for the actual problem. Now, I will come to the section, forget this development. Now, he asks for section of sectional top view and front view and also show the true shape of the section. That's what he asked. You forget about this development part, I am concentrating only this. Okay. So, what exactly the section plane? As I explained earlier, assume that I have any solid. Assume that this is a prism. I cut this with the section plane parallel to the base. What you will get? You will get another prism. You cut hydras, you will get number of hydras. Okay. Here, it's a square prism, you will get another square prism. Only thing is height will change. It all depends on the height you take. Suppose that if you take, this is called truncation, truncated solids. If you incline the section plane with respect to the base or HP, assume that base is on HP. If you cut like this perpendicular to VP and parallel inclined to HP, then this becomes truncated solids. Then you get section. Here also you get section, but the section is square only. True shape is also square. Here also, suppose that I cut like this, midpoint or anywhere you cut parallel to the base. This itself is the section as well as true shape. I have to hatch this. Okay, here also same thing. Suppose that I cut like this, parallel to the base. Then this particular square itself is the section as well as that is cross sectional area as well as the true shape of the section. Suppose that I will cut in this way or in this way. Then the view taken from normal to the section plane, perpendicular to the section plane, that gives you the true shape. That we will discuss. Okay. Now, assume that I have section plane inclined at 45 degree to HP and passing through the top extreme right edge of the solid. What exactly you mean by this? See, this is, assume that I will take a simple solid, square or rectangle. This is the left top edge, this is the right top edge. Suppose that if I keep it like this, other way around, the corner condition in case of solids, all sides are equally inclined to VP, then this becomes, he says, top extreme right corner. Here, left extreme right corner, top corner, like that he says. He cannot give reference, yes, he can give to this also. He can say the mid top point, the edge, the longer edge, it is at the midpoint or passing through the axis. That also he can give. But normally, you will get these two as a reference. It may pass through this or pass through this. Okay. Here, it is rectangle. The section plane passes through this. Assume that the section plane passes through this. If I keep it like this, this becomes left extreme top edge. This becomes right extreme top edge. So, let me draw section plane. How to draw section plane? This is very simple and easy. Now, there is a convention. Assume that I am taking 45 degree from the right, this one, full line, hyphen, full line, hyphen. Almost like the axis, but axis we can keep dot or little small hyphen. Here it is full line, hyphen, full line. There is a convention here. Now, I have made all this dark, but assuming that I have made only light lines at the beginning, I have to dark only the portion which is left. See, this one should be dark, light only. From this point you have to dark, from this point to this point. Whatever the portion above the section plane must be made light. Or initially I will show here, yes. I will keep this light and then show it here. Assume that initially you are made light and then dark from this point. Okay. Now, how to represent this section plane? You have to draw two arrows perpendicular to this section plane. Arrows. In computer it's available. You can utilize it. Okay. Now, this is the section plane and this is the actual solid. Now, assume that I have taken section and then how to name the points of intersection. So, after taking section, of taking section. Assume that this is a rectangle. This is starting point A1, point 1. This is point 1. Here is point 2. Section plane cuts the section solid and gets you the intersection of section plane with the longer edge. No base edge is interacting here. Only longer edges. 1, 2, 3, 4. 1, 2 are visible. 3, 4 are not visible. So let me name the section plane intersection points 1 dash. What about 2 dash here? Assume that this is the height of the solid. The top longer edge, top point itself is 2, that is coinciding with B dash. This is 3 dash, not visible. This is 2 dash, this is 3 dash. If you look from this side, you cannot see 3. Similarly, 4 you cannot see, only 1 is visible. So this is how you name. Okay. So this is to be made dark, this portion. You retain this as light line. Initially you make it light, and then after drawing the section plane, you dark this portion. Now, you look at this in this direction. What is top view? You don't have the top face. Basically, this assume that this particular model I have taken mid point of the axis and cut it. Then here it is, this surface is not available. So naturally you will get this particular section is visible. Assume that you have a cucumber, you cut it parallel, then what you will get? You will get a circle. Assume that it's cylindrical shape. You cut inclined, you will get again from the top circular type only, but you look from the direction where it is perpendicular to the surface which you have cut. You will get ellipse type. Here it is again different. Now this particular area is apparent length of the section. Now what exactly the true length, true shape? Here this is the true shape. For example, this is 20 by 40, but in this case the length of the rectangle becomes 20 by 60. That again depends on this length. Assume that this is m, length is m into 20. Your true shape of the section is m into 20. Then I will discuss that length here in computer. Here you take it as granted. The projection you have made here and you get the view from top is this only. So you try to hatch it. So hatching is 45 degree normally with a equal spacing. This is called hatching of section portion. This is called section. This is sectional view. Why I am calling sectional view? It is representing the section along with the remaining portion, but you cannot experience it in this particular case. You can experience that in pyramids, in the simple cases. Okay, because whatever is available is coinciding with the sides of the section only. Okay, now this is regarding the section of the solid when you take up this particular section plane. Okay. Once I come to this square, again as I told you, if you cut parallel to the base, you will get another square, fine, as a section as well as true shape. Here, let me take same type of the problem. Here I have given 1 and 2. Only the solid dimensions changes. This one remains, section plane and all remains same. Take it as granted, this case 1, case 2. Now let me use this particular figure for that purpose. Assume that initially I have made light line. Yes. Now the section plane passing through the right extreme top corner. Okay. Now you make this arrangement, then dark the remaining portion of the solid of taking section. Yes, already I have made bit. So this is how you have to do it. Again, same type of augmentation. So what exactly is the sectional view and all? See, sectional view is this only after taking the section. See, this is the case. Assume that height of the prism is total and I have taken section plane passing through this. Yes, right extreme top corner. Okay, now let me name this as 1, 2 coincides with B dash, 3, 4. Similar to rectangle. Only change is longer edge, smaller edge. Here is all edges are same. Same thing. 1, 2, 3, 4. 1, 2 are visible, 3, 4 are not visible. Then what about section? If you look from top, you get square only because all sectional sides are coinciding with the lateral surfaces. So this itself is the side which is section 45 degree. Okay, this is section. As well as sectional view. Remaining portion is just below that. All are there. You cannot see anything other than section. So true shape, you look at this, you will get true shape. That we will discuss in computer. So this is about the sections of solids, basics of sections of solids. You get sectional view, top sectional view particularly, and this is front view as they ask here also. Now in case of this type of problem, you have to draw completely the top view because the section as well as sectional view are same. So true shape you will get somewhere here. Okay, you have to project. I will tell you the procedure afterwards. So this is about sectional view and basics of development. I will take the same thing in the computer. So let me consider a square prism with base sides parallel, two base sides parallel or two base sides perpendicular to VP. Then let me have a section plane as I explained earlier, section plane passing through the center or the midpoint of the axis. That is better way of working, midpoint of the axis. So how to draw? You take the line command and then go to this third line. In fact, axis also we used it, but here the other one which is available, which is very long lines are there. These lines are long, but here you can take third one and 0.35, 0.25, anything. Now you can draw through that. See, you will get this section plane. Now the inclined section plane you can draw like this, passing through particular point. Then how to draw the arrows? I will tell you. See, you take this and put like perpendicular lines, always prefer perpendicular lines. This is how you represent section plane, the solid. So what this arrow represents, whatever the portion below is to be retained after taking section, this is to be removed. Okay. So this is the convention we use always. Now how to draw the section? Suppose that you take this a particular square prism you take and cut parallel to the base, you will get another square. At this particular height you get the section, that is cut portion. That cut portion is represented by a command like fill. You can use fill with hatching. That is what I did for you. Now you can click on this and come to this point. The entire area is to be covered by this particular hatching. So how to hatch? Here is given normal, you always take normal, and this 45 degree, see here 45 degree hatching, this is what I am doing now. Hatching is available, but you can change, but normally 45 degree is advised, and this particular gap is given by default. If you want, you can change. So assume that these two are by default, it will be there, and then select the area and click on this. See, I got the hatching. Because partitions are there, you have to go to all partition and do it. Suppose only square is available, nothing is there, you will get the hatching, I will show you how. If only square or rectangle is there, you can always use in one go, it will go, it will work. Say rectangle I will draw. Then I will go for the full line, thick line, and do it. Yes. By 2 points. Yeah. Assume that this is the complete single area. Then you choose this. Now, yes, automatically you will get. So, this is how you can do it. Okay. Now, this is actually referred to as section, this area 1, 2, 3, 4. I can name this as 1, 2, 3, 4. This is 1, this is 2, this is 3, this is 4. I can name, no problem. Let me name along with A1, etc. This is 1, this is 2, this corner is 2, this is 3. Area covered by 1, 2, 3, 4 corners, that is again square, is section. Now, along with section you have complete area, you cannot see this particular solid, remaining portion of the solid is available, that projection is there. D1 and A1, B1 and C1 are there, A, B, C, D are gone. Now, just you retain all these things, you do not remove anything, you say this is sectional view along with the section. What is true shape? This itself is true shape, because if you say perpendicular, axis direction itself is perpendicular, this itself is the true shape. Okay. Now, I will tell you how it is different in different cases. If it is inclined, then you will get different. Now, this is what I have done for you. Next comes the actual view, how you get the section if you take section plane passing through the midpoint of the axis. See, this is the actual solid, you have taken the section plane parallel to the base, you will get the section. This is what we represented here. Okay. Now, next comes this. For example, you take inclined surface, inclined section plane, then you will get it. Then the problem is here, take one problem and discuss. See, here I have taken the section plane passing through the midpoint, inclined at 45 degree. Okay. Now, what is section? Section is 1, 2, 3, 4, as I explained earlier. See, the section plane is intersecting the two longer edges at 1 and 4, 1 on A1, 4 on DD1, then 2 on BB1, 3 on CC1. Now, you decide 1, 2, 3, 4, again it is clockwise, anti-clockwise. See, here you have to come like this. See, this is first point, second point, third point, fourth point. So, same thing I can represent here also. See, 1, 2, 3, 4, whatever I have identified, I can represent here. 1, this is 2, this one is 3. This is the projected points on the longer edge. Suppose that you have a pencil perpendicular to the HP you have kept. The midpoint of the pencil is again same point on the top view. So, same thing here you have, this is the line which is perpendicular, A and A1 is there, and that point only 1 also lies, that is what I mean. Now, this is the section and sectional view. What about true shape of the section? Here what I have done, I have taken this direction as a reference, see, perpendicular to the section plane and projected. So, what you have to do is you consider x1, y1, there are two ways of working. Consider x1, y1 at convenient distance, completing all the figures is over, now it is free now. You take this x1, y1 at any convenient distance from this. Then take all the distances, normal perpendicular distances from xy on x1, y1 and the respective loci. See, this is locus from 1 and 4, this is locus from 2 and 3, perpendicular to this plane. Then you take the measurement. See, xy to 4, as I told you, xy to 4, xy to 3, same distance. Next, xy to 1, xy to 2, same distance. So, assume that this is 10 and this is 40 total. Here it is 10 and total is 50, like that. With compass only you can take and do it. Otherwise, in computer you can measure and say so much. Now, you will get the true shape. You join all these 1, 2, 3, 4, you get true shape. You dark this boundary and hatch it again. Okay. So, this is how you get the sectional top view, section and also true shape. This is called true shape. What is true shape? Again I will repeat, if you take view from a perpendicular direction to the section plane, you will get the view. So, this is the thing, but true shape of the section. Otherwise, you can also use, suppose that the distance is very small, you cannot accommodate x, y and this gap and all. Then you take line of symmetry, see this is line of symmetry. If you take only one distance, you can complete all 4 points in one go. See, this is line of symmetry. So, this is from line of symmetry 1, 2, 3, 4 all are equal. From this you draw 2 arcs, again from this you draw 2 arcs, otherwise if you take same distances, you can complete the show. Here xy is not, x1 y1 is not necessary. Actually x1 y1 is auxiliary inclined plane. So, basically we were talking about the change of position method and ground line method. This is concept of ground line method. I have changed the ground line itself and called that as inclined plane and got the true shape, that is what. So, otherwise it is not a problem for you, just take the x1 y1 and take the corresponding distances, perpendicular distances from xy and pass on to x1 y1 and the corresponding loci. Next comes the prism. Before that, let me go to rectangle and show you how exactly this particular item is there. Yes, this is rectangle. I have the, let us not consider the development now, let us concentrate on only on the section. Assume that there is a rectangle prism with 40 mm and 20 mm and as he says longer base edges parallel to VP, I have taken it, and then the actual thing is section, we are concentrating how to draw section. So, what I do is I will cut this particular solid in such a way that right extreme edge is passing through that. Now, the section looks like this. If you look from top, you will get apparent shape as a regular rectangle, so 40 by 20 only, but if you look from perpendicular to this, definitely 20 by this distance, say this is around 60, okay, 60 by 20 you will get if it is 60, otherwise any distance you take in by 20 you get the true shape of the section. So, how to draw? See, draw section plane and hatch this particular portion, and as I did here in this case you take the as per square you take perpendicular and get the true shape. Now, here I will draw the section. How to draw the section? Take the hatching. Okay. Sometimes you never get. What you do is you retry. That's all you get. So, in this case of development, you need not have to hatch it. There is a specific question, draw development only. So, here just for the basics, I am showing all this. Okay. Now, let me move to the sections of solids. Yes. Now, in case of section of solids, if I take up the square pyramid, this is the top view when the base side is parallel to VP or one of the base side is perpendicular to VP. Then for a given height, this is the front view and this is top view. Now, assume that I am taking section parallel to the base, then what exactly you get? You get another square of smaller size, because the slant edges are decreasing the area of the cross section as it moves towards the vertex. As it moves towards it, ends up with a point. So, it is maximum at base and here. So, if you project it, definitely you will get this. Now, how to get it? I will tell you. Now, here is the procedure. You project on the, you see that this is intersection, project on the respective. What exactly this? This is point 1 and 4. Let me name the points. Basically, how to name the points of intersection. This is 1, it is intersecting the slant edge VA. 2, 1 dash particularly because it is front view. 2 dash is the point of intersection with the section plane and the slant edge VB. Similarly, in bracket you have to keep 3 dash, 3 dash, and in bracket here 4 dash, because the slant edge VD is intersecting at 4. Now, how to represent the same here? Yes, you just project on the respective slant edges. See, I have projected 1 and 4 on VA and VD. So, what exactly this point? Here is 1 that is intersecting at VA and this is 4. So, in case of prisms, you know, it coincides with the same point because it is vertical. This is 1 and 4 because it is slope, definitely you will get these points. Now, project 2 and 3. Project 2 and 3 intersection, bring it down vertically, see that point is there. Now, you see that this particular item is for section join 4 and this point, definitely you must get horizontal here also. This particular item is called section. So, parallel to the base, definitely this itself is true shape. Okay. So, what exactly sectional view I will tell you. First, let me hatch the section. So, hatch this. Now, this is section 1, 2, 3, 4 I have to name. This is 2, this is 3, yes, 1, 2, 3, 4 is the section. What about sectional view? Section along with the remaining portion, it is very clear here, you can easily understand along with the remaining portion. So, dark all these points. See here actually you have to dark this portion with 0.5 or 0.5. Yes. You can redraw or you can select those and change it. Better you select this. Yes, select this and also this one, boundary of the section. If you select boundary of the section, you have to bisect, select. See, this is 0.5. Yes. So, along with this also has become boundary. We can split and then change it. It happens sometimes. See, this also become dark. So, you select. You go for split, so that you will come to know what is split. Many times we use split at this point. Again, you also experience same thing, you try to do this, then select this and make it light, or initially you can do that job. See that all they are independent items. Okay. Yes. Okay. Now, you have projected this and got. Now, you have to dark. This is very important key points. 1 to A, 2 to B, 3 to C, 4 to D, all are dark. If you do not dark it, then there is wrong. Okay. So, it is not completed one. So, what you do is you select the line with a dark that is 0.5, and you can select this, or again same problem you get. Otherwise, you go for, you redraw again T to 3, again draw lines with that particular thickness. See that all points are covered. Yeah, this is nothing but sectional top view. Front view, section. What is front view again? Front view is you have to dark this remaining portion. Otherwise, again it is wrong. Okay. This is, next comes the, whatever I have taken here, assume that I have taken parallel to it, you will get. So, this is what? The sectional view and also section and section plane, etc. So, these are all very prerequisite for your development of surface. That is why I am covering it. Now, if you take inclined section plane, it looks like this. Okay, you will get a trapezium. Okay. Now, for what purpose? See, here it is parallel. Now, I have one I will show you the inclination. See, this is the inclination. For inclination, inclined one, this is at the top. As it reaches the apex, you have smaller length, and as it reaches the base, it is having bigger one. Same procedure. You select this point, draw 45-degree line, and then extend it, then try to project all these points 1, 2, 3, 4, etc. While working on development, I will explain clearly, and here as per section consent, you have to do this. In development, you need not have to do all these things. Now, project it and get hatched this one. I will show you how to hatch again. Again, same thing. Try to zoom it. Sometimes it may not come, it will come like this. Again, yes. Again, you have to dark this along with the base and these edges. 1A, 4D. Earlier, 1A, 4D and all are equal. Here it is different because it is inclined. And what about the section? This is not the true shape of the section. You look from direction perpendicular to the section plane. Perpendicular to the section plane, you will get the true shape. I will show you how you get. See, this is how you get. You draw this one and say x1, y1. If x1, y1 is not convenient, you go for this. See, x1, y1 is far away from this. Now, I have taken only section, the symmetry, line of symmetry and did it. Now, this particular item will become this one. See, this is 1, 2, 3, 4. Forget x1, y1. After that, you can keep x1, y1 anywhere suitably. And here only you can keep what distance you have maintained, that only you can keep. Now, the 1, 2, 3, 4. See, 1 and 4. This is 1 and this is 4. This is 1 and this is 4. This is 2 and 3. So, hatch this. So, let me name. Assume that I have projected and got this. This is 3, this is 4. Now, hatch this portion, dark it basically, select and dark. Okay, redraw. Sometimes the part of it may not be this one because you have drawn earlier or later stages, then you draw again. Now, hatch this portion. See, here you are getting almost parallel because already it is inclined. Then you can change the angle. So, this is the opportunity for me to tell you how exactly you can change the pattern angle. Now, here it is already 45-degree, that is why you are getting parallel. Now, you can change to 60-degree, okay, 60-degree. See, now you are getting somewhat hatchet type. Otherwise, again 45-degree also you can use because the 45-degree to this means it is almost 0 degrees. So, otherwise let it be around 30 or 60. Okay. Now, this you have to complete, as I said, you dark this and hatch this, this becomes section, and remaining portion also you have to dark 1A, 2A, 3C, 4D, whatever I told there. Then you hatch this. Then that becomes sectional top view. Okay. Now, we will take up some problems of the same type with different orientation. So, here I have completely taken out the top portion including this corner or below that. Here portion of the top portion is retained. How exactly it looks like. So, now I draw. This is the question on the development, but let me teach you how to keep the section for this. Now, for this it is very easy. Here sectional points are this 1, 2, 3, 4. You take this down with thin line. See, 2, 3 also you continue. Now, it is very important that 2 and 3 are very important points, key points, because 2 and 3 are not vertical, are not on vertical edges, they are on base edges. Here I will just take this one. See, 2 and 3 are base edge, top face edges. Let me name. Here it is 2, this one is 3. Okay. Now, this is 1, this one is 4. So, what to do? Here I have to hatch this portion. Before that, dark this, because whenever you cut a surface you will get an edge, clear cut edge. So, let me select this and dark this line. Now, I redraw again, take dark line and redraw this. Okay. Now, this portion is nothing but section for this particular problem. Not complete area, because we have taken section from this point. See, sectional plane passing through a point on the axis 10 mm below the top end and inclined at 45 degree to HP. Okay. So, this is the only section. What about sectional view? Top sectional view is this only, because the top surface is complete is available, but you cannot see, that is everything is just below this section and this portion. But when you draw true shape, then you will get this true shape. True shape dimension becomes your 40 and length of this section plane within the solid. Okay. Or even you can draw the sectional view along with the true shape, that you need, do not worry, because it is not in your syllabus. Next comes the various types of this. See, here also I have taken other orientation, sides are equally inclined, then section plane is inclined, then this area you have to hatch and you have to draw true shape in this direction. Then what you do, you see XY or line of symmetry you keep, then get the true shape. Okay. Then comes the circle with the height, that is nothing but cylinder. Okay. If I cut parallel to the base, then you will get the circle only as the section as well as true shape. Suppose that if you cut the generators and inclined, then you will get definitely true shape as ellipse, the top view section is circle only. Okay. Then that we will discuss at later stages. Now, let me take this, and if you cut this, you will get another hexagon as the hatching portion. There are many other shapes, okay, which definitely will work in the case of development. Whenever you come across development, we will tell you. Now, if I take up the cone cut parallel to the section plane, definitely you will get the circle again, you hatch this portion. This is the sectional view, because it is having slope, definitely you will get the remaining portion. Same case in cylinder, you never get, you get just circle, whatever is retained, it is just below that. Okay. Okay. Something like that you are supposed to get. Suppose that it is inclined plane, section plane, then you will discuss that in the development portion. Wherever opportunity comes, I will tell you what exactly the section. Okay. We will discuss in the next session development of surfaces of all types of solids and cones and cylinders.